Okay, welcome Alexi and Sarah and Susanna and Regnian, Fanria, Stefani, Diego and Bruno and Adam. Thanks for showing up. Let's go right to that quiz. Okay, so here's the quiz. And I copied and pasted it into the answer box so that we can easily do it. And it says, consider the sequence, AN equals 8, 10, 12, 14, 16. I hope you all see the pattern. I tried to make this easy, where N starts at 1. Write AN as an explicit function of N. So what is the strategy for doing this? Any suggestions? There's a couple different possible strategies that will work. Any thoughts?
I did 8 plus 2n.
You did 8 plus 2n. Okay, that almost works. Okay, so that's a strategy of guessing at one and hoping it works, that kind of thing?
Well, it was a strategy of the first term plus the difference between terms.
Okay, so your strategy was recognizing this. Let me put it in words from pre-calculus as an arithmetic sequence. Is that right?
Yes.
You recognize this as an arithmetic sequence, and that definitely works, but you got to be careful because
N work every time. I know.
Because n starts at 1, not 0.
I know, but I said 8. I said 8 plus 2 n's, and then the first term is 8 plus 2 1.
Right, but that would give you 10, but the first
10,
term
yeah.
is 8.
Okay.
Okay, so if you recognize it as an arithmetic sequence, then you got to remember the formula for arithmetic sequence. And so if we do it that way, it's AN is equal to, it's the first term plus the difference. Sometimes they call that D, the common difference. And if you subtract any two successive terms, you get 2, right? 10 minus 8 is 2, 12 minus 10 is 2, etc. So you would have 2, but it's not times n, it's times n minus 1. So that way, when n is 1, you get 8 plus 2 times 1 minus 1, which is 8. And that's what we want. Does that make sense? Okay, had I said it starts at 0, then 8 plus 2n be correct, but we're starting at 1. Does that make sense?
Yeah, it does. Thank you.
Yeah, so the other idea, you just made one little mistake, it sounds like. So just a note, there's other ways of doing this. The other way is realizing that this is linear and the slope is 2. And you just do a good old y equals mx plus b, and you'll find out that that it all works out nicely. And you'll end up with the same thing. You'll end up with something that looks like 2n plus 6, which is exactly the same thing. Any questions on part A? Okay, for part B, it's right as a recursive function. So with the recursive function, what information do you have to give? Let's put it this way. What 2 pieces of information do you have to give? You have to give the first term, and that's supposed to be very easy if you have a list of terms. What's the first term? That should be the easiest question in the world here. 8. Okay, so we can say that A1, because I'm starting at 1, so it's A1 equals 8. And then what other piece of information do you have to give? Do you remember?
Either n plus 1 or n minus 0, depending on how you write the sequence.
Yeah, let me put it in words. You have to write how you get to a term using the preceding term. And you can choose whether you're going to call that term n or n plus 1. I'm just going to go a sub n plus 1. I'll just write it that way. Is equal to, well, if we're at a term, what do you have to do to get to the next term?
Add 2.
Add 2. So that's going to be an plus 2, and that's it. Any questions on part B? Okay, you could also write an equals an minus 1 plus 2. It's exactly the same thing.
Larry,
Okay.
I wrote a naught equals 8. Is that
The problem with that is read the directions.
doesn't that then not be included in the series? Like, so if you added the way I wrote it, if you start with 1 though, it does come out to this proper sequence. It just
There is no
Is
a
that-
naught. That's the whole point. If we're starting at 1,
Okay.
there is no a naught.
okay. I guess it's semantics then. I see.
Yeah, it's not semantics, it's mathematical definitions. Let's put it that way. Yeah, there is no a naught if you're starting at 1. There is only an a1. Does that make sense? Yeah. So
Sort of. Yeah. I mean, I get what you're saying. I want to disagree, but I'm not going to.
yeah, if you start at 1, then there's no a -7, there's no a -3, there's no a naught, there's only an a1 is the smallest one, the smallest index you can get is 1.
Because I got an example that used a naught. It just wrote it and it said the series starts at 1. And so that's why I thought it.
Then
so
that
I don't-
example wasn't a good example. It wasn't one of my examples, that's for sure. That's just bad. That's just wrong, actually.
I'll take it up with whoever it was then.
Yeah, whoever gave you that example, it wasn't me, because I wouldn't do that to you. But I wrote start at 1, that way it'd be consistent throughout the whole problem. What I did tell you is that sometimes you start at 0, sometimes you start at 1, depending on the context. So I gave you the context of starting at 1. Does that make sense? And once it's given, you got to stick with it. Okay, is AN bounded? Yes or no? Yeah, this one's a no. A lot of this is just, do you understand the vocabulary? That's all this really is. So AN is not bounded because 8, 10, 12, 14, 16, if it was bounded, then you could say a number and it'll never get above that number. But these numbers get higher and higher and higher and it'll get above any number you say. Okay, any real number. So no, since it goes off to infinity. So it is not bounded above. Okay, so there's no highest value at which you don't get above that highest value. Any questions on that? Okay, and if it's not, for being bounded, you have to be both bounded above, below and bounded above. Okay, is AN monotonic? Again, this is all about, do you remember the words? Is AN monotonic? Yeah, this one's a yes, because monotonic, if you remember, that means that you either always go up or you always go down. You don't go up and down and up and down. You just stay going in one direction, but this is monotonic, and in fact, it's monotonically increasing. So this is yes. It is monotonically increasing. Any questions on that? Okay, let's do the next one, which is the last one. Does a sequence converge or diverge? Explain your reasoning. What's the answer to this one? Converge or diverge? Yeah, this one diverges. Right, and it's diverges because it's not bounded and it's monotonically increasing. Okay, so that makes it diverge. So since it is not bounded from above and it is monotonically increasing. Okay, and any questions on that idea? The other reason, here's another reason, and that is you can look at f of x equal 8 plus 2x minus 1. okay, which goes to infinity as x goes to infinity. Okay, so what does that tell you? That means the sequence goes to infinity. Okay. And I like to call it by the limit test. The book doesn't, but it's an easier test to say, and I think it's easier to remember. So let's call it the limit test. I think the book calls it the divergence test, but I like limit test better. So you'll see both in different places.
So is the so this isn't bounded from below? Like
Yes, it
I
is
thought that
bounded
because
from-
it doesn't go.
Like on an iPad, so
I thought that because it doesn't go below the value of 8.
Yeah,
that
it
it'd be
is
bounded from below.
Yeah, it is bounded from below, but the word bounded means both above and below. That was part of the definition.
So.
All right, yeah, I wrote
Yeah.
that in my notes, but I guess I didn't read it carefully when I was doing this.
Yeah,
quiz.
so AN is bounded if AN is bounded from below and from above. So if one of them fails, then it's not bounded. If both fail, it's still not bounded. Does that make sense?
Yes.
Yeah. And again, the limit test quickly shows that this diverges. Okay, which the book I think calls the divergence test, but I think the divergence test doesn't give you enough information. I like the word limit better because that's really what you're doing. You're taking a limit. Okay. Any questions at all on this question? Any questions? Okay, if not, are there other questions about anything else? Open it up. Can we look at 13 from the homework? You got to tell me what 13 is. Remember, everyone has different 13s. So I can't read your mind and know what 13 is because they're randomly generated. So if it's easy to state, then I can look at it and help you out with it. It looks like you copy and paste because that was a lot of typing if you didn't. So a lake initially contains 4,500 fish. Suppose that in the absence of predators and other causes of removal, the fish population increases by 6% each month. However, factoring in all causes, 300 fish are lost each month. Okay, how many fish will be in the pond after 9 months? Don't round until the very end. All right. By the way, this particular problem is an important problem, but it's a classic problem in a different field that you probably have learned already in pre-calc. Do you know what this relates to? What kind of problem? Yeah. This is well, it's not quite PERT actually, because PERT is when you have a continuous loss. But here we don't have a continuous loss. We have a incremental loss. Does that make sense? Okay, loss and gain. So PERT is the limit as the increment goes to 0, but we're not doing that. We're actually sticking with each month. But it's kind of the idea of PERT. Maybe that's what you were thinking. So let's look at this. The first thing is I'm going to write it because it's easier to kind of write. So I'm going to write this whole long paragraph. I'm going to write it recursively because I think that's easier to do. We know, and I'll let you choose. Let's see, after 9 months. Yeah, let's let 0 be our beginning. So we can say a sub 0 is equal to 4,500. Any questions on that idea first? Make this a little bigger. So that's not supposed to be too hard. Okay, let's write the recursive equation because I think it's easier to talk about that way. At least we have all the information. And that is a sub n plus 1 is equal to, so if you know what the last one is, how do you get the next one? We got an increase of 6%, but then at the end of that month, you know, a fisherman grabs 300 fish. Look at it that way. So any idea how that works? Yeah, right. So it increases by 6%. That means you multiply by 1.06. Since I wrote n plus 1, we don't need to do the n minus. It's not n minus 1. It's just going to be a sub n. So it's going to be 1.06. Oops, 1.06 a sub n. And then minus 300. Yeah, so a good question is, let's read the question and see what they mean. The fish population increases by 6% each month. Okay, but 300 fish are lost each month. I think based on the wording of this, that means at the end you're losing 300, not at the beginning. Okay, it's complicated. And you try one way, and if that got it, if not, then try it the other way. And again, from the wording, it could go either way because it's not the most specific. Okay. So there's kind of the brute force way of doing it. And if we're using this equation, well, let's get A1. And A sub 1 is, well, we're starting with 4,500. So we get 1.06 times 4,500 minus 300. And I am going to pop that in the calculator. And it gives me 4,470. Any questions on that? All right. How do you get A sub 2? Hopefully it should be obvious. Hint is I copied and pasted it. Yeah, we just used the previous term. We turn that 1 into a 2. We turn the 4,500 into 4,470. Put it back into the calculator. And if you round, you get 4,438, but you're not supposed to. 4,438.2. Any questions on that? I don't think I want to waste everyone's time and do A sub 3, A sub 4, A sub 5, A sub 6, A sub 7, A sub 8, A sub 9. But do you get the idea of how to get these? Any questions on this? Okay, and that works. Okay, and that works. And if you get the wrong answer, it might mean that what they meant was they want to take 300 away at the beginning and then multiply by 1.6. And so if that were the truth, then you would say that a sub 1 would not be 1.06 times 4,500. It would be a sub 6 times 1.6 times 4,200. And you don't have to do the minus 300 because we already did this. Okay. And then whatever that is, 1.6 times 4,200. And you get 4452. And then do the same thing, except now we're going to say 4452. And minus 300 is 4152. Put it in the calculator. It's a bit tedious. And you get 4401.12. Okay, anyway, you get the idea? And it sounds like a few of you did it that way and it worked. Again, I don't think the wording is the best. I'll have to look to see if I have the prior. I didn't write this question. I'll have to see whether I even have editing privileges or not. If not, then I'll email the person who wrote it saying, hey, you know, please put in some better ways. So Sarah, you got it the way I did it the first time. Yeah, it's a little hard to tell by the wording. So try them both and one should work, hopefully, is the idea. But Bruno, does that make total sense now? Yeah, sounds like you understand. Are there other questions? Because today's all about examples anyway, so questions are fine. Okay. And if you don't have questions, then we'll do more examples. So we got another one here. And now it's a college loan here. So a student takes out a college loan at $6,000 at an annual percentage rate of 5%, compounded monthly. Okay. And if the student makes payments of $400 per month, how much to the nearest dollar does the student owe after 6 months? Don't round until the end. Okay. And now, since this is a loan, nobody makes the first payment at the moment they make the loan. You always wait till the next month. So this one's definitely, at least it should be, if the author wrote it correctly, this one's definitely is the 400 is taken out at the end of each month instead of the beginning. Okay. So it turns out this is exactly the same as the one we just did with different numbers. Okay. But instead of money in a bank, fish in a pond, we got money in a bank. But it is no different. Do you agree? Okay. You can also use the A equals P times 1 plus R over N to the NT. Let's see. Yeah, see, the problem is that only works if you're not taking money out. It's a little more complicated. Yeah, so notice if it's percentage rate, if it's an annual percentage rate of 5% compounded monthly, then that means each month it's 0.05 over 12. Does that make sense? Yeah, it's full of tricks. Okay, so each month, so let me just kind of write it out at least the beginning. Each month it's going to be, let's write this out, A naught. I'm just going to do this because literally it's the same kind of question. So A naught now is, I got to scroll up to see how much it was, 6,000. But you'll see there's a very similar question. And then A n plus 1 is going to be now 1. I'm going to write it this way, a little different than 1.06 because too hard to do in my head 1 point that way. So I'm going to write it as a 1 plus And let's see, what was the percent? 5% compounded monthly. So that's going to be a 1 plus 0.05 divided by 12. And then we're taking out how much? 400. Any questions on that? And the question is, what is A6? Okay. So it doesn't sound is based on the fact that I just kind of did one of these. You understand what to do now? How to get A1 by plugging in. Oh, I forgot to write times AN. So how to get A1 plugging in, you plug in 6,000 right here. That'll give you a number. And then you take that number, you plug it in, gives you a new number, et cetera, et cetera. Good. Glad you get it. And then hopefully you see whether it's fish or money, the math is really the same. I hope you all see that. There is a divide by 12. That's kind of tricky because it's compounded monthly and not compounded annually. And it's put in every month. Okay. No, it's compounded monthly, but it's 5% annual. So it's a little tricky that way. Any other questions? Any other questions? If there aren't any questions, I think I'm going to move on to what I consider the most important mathematics there is right now. Anyone know what that is? And it's something I wasn't able to find anywhere. So I might be the first to do it, but I doubt it. And I don't mean right now in this class. I mean right now, like for the world or for the country. Let's call it the country. Yeah. So the question is, and I don't know if you've all thought about this, but I think deeply about this stuff, and maybe because I'm a math nerd too, is where are we going? Okay, when it comes to COVID. Okay, I got some plans. I'm actually hoping to do a little traveling in October. Can I? Is it safe? Is that a good question? Okay, what if you got a big plan at the end of July? Should you worry? Okay, or maybe you shouldn't worry. Any questions on that question? So, kind of the way I wrote the question is, when will this nightmare be over in the United States? Okay, so that's the big question I had is, we know COVID's a problem. If you don't know that, then I don't know where you've been. But the question is, what's it going to be like in end of July or August or even in late June? Does that make sense? So I thought I would give you something very real world. This is as real world as it gets. And what was even more frustrating, I spent over an hour looking online, trying to find a good model, trying to find out what someone else has done. I couldn't find anything. Okay, so what I did is I realized that what we're doing actually works real well with creating a model. Okay, so we're gonna create a model. Okay, and we're gonna see what it's gonna look like over time. What can you plan in 2 months? What can you plan in 3 months or even 6 weeks? Okay, so the first thing I needed to do, so I'll tell you what I did to start it out, and then we're going to do the rest together, is I searched online to see what kind of data there is. Okay, and that was even hard to find. It's amazing. I mean, I wish the news did better, but finally, it took a long time, actually. I found something in the New York Times that was useful. Okay, and it was just kind of, that's where I got sent. after putting in countless different questions in Google. I finally found one that would help, nothing with a model. None of them had that. So here's the New York Times piece that I found. And what this is this is a graph, and you'll notice it's all over the place. And we had an awful time. We had an awful time at the beginning of the year. I don't know if you remember. It was a disastrous time for us, COVID-wise, in the United States. And this is a graph of where we were and where we are, you know, and how we've been. Any questions on that? Okay, the next thing I looked at was I did some more research. Again, there's a lot of research to find out a major thing, and that is how long you are infectious. Okay, anyone know, by the way, on average? From the time you get it, hopefully you don't get it, but the time someone gets it to the time that you it's not so bad anymore. Yeah, it turns out it averages 10 days. 10 days is the average. And I'm going to go by the average because that's the best I can do. Average seems to make sense for a model. So 10 days was the average amount of time. And so I'm going to go by it takes 10 days after you get it to when you really should stop when you don't need to quarantine. You really should be quarantining for that time. You know, as long as you're contagious, you should be quarantining if you've got it. Hopefully you believe that. Otherwise, you're just selfish. Okay, so we want to make sure that we're using all the information that's going to help us figure out what it's going to be like. So I got a bunch of questions. Okay, so I just wanted to show you this graph, by the way. And one of the nice things, you'll notice that in the last month, what's happening in terms of COVID? Yeah, it's going down. It's going down. And not only is it going down, this makes this made me smile in terms of math. It's a pretty constant rate. Do you see that? Okay, there's a somewhat constant rate of going down, which is nice. Okay, because it makes the math a little better. Whereas if we were over here, forget models because it's all over the place. But now it looks like we have gotten to a point of some good predictability. Any questions on that? Okay, so you'll notice that the 7-day average, by the way, is, you know, around 31,000 or 31,000 cases. And what I did is I multiplied it by 10 and rounded up a bit because it's 10 days. And if you do a 10-day, multiply by 10 and go up a little bit, you'll end up with about 350,000 Americans have contagious COVID. Any questions on that small calculation? Okay. So again, I did some research. On average, a person is infected remains contagious for 10 days. Okay. The transmission rate. Do you know what that means, transmission rate? Per person? Anyone know what transmission rate means? Yeah, it's how many people a person who just got COVID is going to eventually infect. Okay. You want that to be low, by the way. And I did a calculation, and I did the calculation based on the following. I'll show you. I looked at what it is now. I looked at 10 days ago. And then based on what it is now and what it was 10 days ago, I was able to figure out what the transmission rate was. Okay. So the transmission rate was 0.73. Any questions on that? Okay, if the transmission rate is 1, what would the graph look like? Yeah, it would look flat, but even more horizontal. Be a horizontal line. So it'd be a horizontal line. If the transmission rate is over 1, then it's going to go up. And if the transmission rate is under 1, it's going to go down. That makes sense? Right? If you're giving it to fewer than one person on average, or everyone gives it to fewer than one person on average, over time, there's going to be fewer people that have it. Okay. But remember, we got 350,000 people with it. So if it goes down slow, we still got a problem for a long time. So this is a transmission rate. And so here's some questions I have. And I'm going to have you guys kind of work it out. And then, I'll work it out with you too after, is one piece at a time. So let's create a model. Okay, again, I want to do something real. And this is, hopefully you agree, there's nothing more real today than this in terms of, importance and what everyone's dealing with. So let's actually do this. And what's cool about it is it relates to just what we're doing. So let AN be the number who are contagious at time N. Okay? Where, for example, N equals 3, sorry, that should say, I made a mistake, corresponds to 30 days from now. So because you remain infected for 10 days, I'm going to let 10 days be my unit system. And you get to choose that. You always get to choose your unit system when you're creating a model. And by letting 10 days be my unit system, it makes it a lot easier, because that way, when at every step, we have a new set of contagious people. Any questions on that? So N equals 3 corresponds to 30 days from now. Okay. Construct a recursive model for the number of Americans who will be contagious over time. So I want you to do that. And let's see if you can work that out. Put it in the chat box when you're done. And I'm going to scroll a bit so we can have it all on one page. And again, I'll give you a minute to find a recursive model for the number of Americans who will be contagious over time. So in other words, you need to write down what AN plus 1 is in terms of AN, and also what A, either not or 1. You can choose whether you want to start with 1 or 0. That's totally up to you. In this case, I think it's easier to start with 0, to call today A naught, than to call it A1. And that way you're talking about every item. So N equals 3 is 30 days from now. So N equals 0 is today. Just let you know that. So we're starting at N equals 0. So let's see if you come up with a recursive model. And this is not like deep and really hard. I'll get into some harder stuff in a bit, but this isn't supposed to be too hard. And give you a minute or two. Shouldn't take long. And put it in the chat box when you've got it. Let's see if 2 people get the same thing. That's what I'm hoping. And I will let you know that, this may be depressing and stuff, but it won't be. I promise. When we're done, you're going to be smiling when we're done with all of this instead of sobbing. Okay, so we got 2 people with the same thing, and that's correct, which is great. So the first thing is, typically, by the way, you write down A naught when you do recursive models. I mean, that's just style, but I'm just telling you what most people do. So A naught is today, and that's 350,000. And then AN plus 1 is going to be 0.73 times AN. Any questions on making a recursive model for the number of people in the United States who are going to have COVID over, at any 10-day interval? Okay, so notice if n is 10, we're talking about 100 days from now. Okay, if n is 4, we're talking 40 days from now. So these aren't day by day, these are 10 days by 10 days. Any questions on part A? Okay, let's do a next one, which you might be able to guess. And that is construct an explicit model for the number of Americans who will be contagious over time. See if you can do that. And that one, it's all or nothing. Either you look at it, you say, oh, this is easy, and it'll take 5 seconds, or you'll sit there forever not knowing what it is. But it's actually really easy. And let's see if you can come up with it. Again, the hardest part is just typing it in the chat box because it's really simple. And it's not even that hard. So what's an explicit model? Because we just did a recursive. And what I like about this is that this is not even a stretch in terms of, kind of doing math that really doesn't relate to what we're doing. This is exactly what we're doing this week. And it just so happens it's the most important thing going on right now, I think. So what is an explicit model? See y'all jumping in. If you have no idea, you can just say I had no idea, or you can tell me. But hopefully all of you can figure it out. So what's an explicit model now that we got a recursive model? Remember, that would be a sub n is a function of n. Any ideas? Should be quick. Either quick to give up or quick to get it. You're all being quiet. Okay, so let me explain. Let me go through. No, okay, let me go through. Let me go through some reasoning instead of just saying it's obvious because it's not obvious to you. I see that as a group. All right, so what we're gonna do is we're gonna start out with 350,000. A sub 1 will be 0.73 times 350,000. A sub 2 will be 0.73 times 0.73 times 350,000. Any questions on looking at A sub 2? Maybe I'll type that out so I don't lose you. So A sub 1 equals 0.73 times 350,000. A sub 2 by the recursive says that we're supposed to multiply that by 0.73. 0.73 times 0.73 times 350,000. Now, for 2 reasons, one, to make it prettier, and the other is to see what's going on, I can rewrite this as 0.73 squared times 350,000. Okay, what's A sub 3 going to be? Hopefully you see the pattern. Yeah, 0.73 cubed times 350,000. So now we're ready, hopefully, to write down what a sub n is. So a sub n is equal to 0.73 to the n times 350,000. And typically you write the number first, 350, 000 times 0.73 to the n. And I'm going to make that bigger because it's really important. Put it in red. Okay. And I don't want to say, you need to memorize this for our course, but I think it's important. This gives you an idea of what we're going to look like over time. So now we can start answering all kinds of important questions. How many will be contagious by the end of July is the next question I've got. Okay, people, people ask that kind of stuff. They're thinking about making plans, right? Maybe doing some traveling, whatever, and they want to see how safe it is. Right now, we got 350,000 people contagious. What about the end of July? Is it going to be worse, better? See if you can tell me. Okay, you will need a calculator, by the way. And just a hint, it is May 19th today. You need that. So let's see if you can tell me how many will be contagious by the end of July. All right, see if we have someone that agrees. Okay, what do you get? I want a number. Not 73rd power, definitely not 73rd power, because that would mean the time would be 73 10-day periods. So remember, n is 10-day periods. Yeah, so it's not 73 days that matters. It's how many 10-day periods there are. Yeah, or just 7 periods. Yeah, whole number is probably better, just easier. Yeah, so it's pretty easy. All you do is you take the equation and you put in, first you have to say, well, right now we're May 19th, June 19th, July 19th, that's 31, that's 61 days. And then another 10 days or so, 71 days, and a little bit more, but basically 7 time periods. So around 7 time periods, and if you take 7 time periods, you just plug in. So we just say a sub 7 is equal to 350,000 times 0.73 to the 7th power. I definitely can't do that in my head, but we can put it in the calculator pretty simply. And we get 350,000 times 0.73 to the 7th. And it gives you about 38,665. I'm going to say 39,000 because remember, this is just a model, lots of estimates. It does not make any sense to having to say that I know it to the exact person, but maybe to 10,000. So around 39,000 people. Any questions on that? Okay, here's the next question. When will there be fewer than 10,000 contagious people in the United States? How do you figure that out? It's not that hard. And let's see if you can come up with when there will be fewer than 10,000 contagious people. Okay, and that will take a bit. There's a little bit of math to do on this one. It's not just arithmetic, but no calculus. This is all pre-calc, actually. Kind of this whole the assignments due today and Friday are all pre-calc, which means I can spend some extra time doing an important example that I've never seen anyone else do. Maybe I'm first. I don't know. Okay, I see 113 days. That might be right. I can't do it in my head. Let's work it out. So what we can say is that's saying that we're going to have 10,000 for A sub n, and we need to find n. So that means 350 350,000 times 0.73 to the n is equal to 10,000. Okay, I could just divide by 350,000 and you get 0.73 to the n is equal to 10,000 over 350,000 is 1 over 35. And then if you remember the way you solve that, who remembers how to solve something like 0.73 to the n equals 1 over 35? Pre-calc. Yeah, take a log. So we can say n natural log of 0.73 is equal to 1 over 35. And the divide by natural log is 0.73. So we get n is equal to 1 over 35 divided by, let's put all that in parentheses, natural log of 0.73. Any questions on that so far? Oh, you know, I forgot the natural log of 1 over 35. And then I can write that down as a natural log of 1 over 35 is negative natural log of 35. Yeah, we'll get to all that later. That's going to be coming up, but we're starting out with easy. And then I wonder if this will work. Copy and paste it in the calculator, into Google Calculator. and you get 11.3. So good, good. So 11.3 multiplied by 10, and that's how many days from now? So about 113 days from now. Not exactly, because it's a model. So this will happen in around 113 days from now. Any questions on that? Any questions? Okay. So now, next question. How many total Americans will eventually become contagious from now on, basically? So I'm not looking at the past. I'm just looking at starting from today. How many total Americans will become contagious? What is this asking for? There's going to be a limit, but it's a little more complicated than that. And the key word is total. So the eventually gives you the limit, but what about the total? So definitely a limit's going to happen. And what about the total? Yeah, that's the sum. So now we're going to be taking a sum from n equals 0 to infinity. Okay. When we're talking totals, a model, obviously infinity never happens in the real world, because after, a 100 billion or a few 100 billion days, there won't be a sun. And when there's no sun, there's no earth either. But we're going to not even think about that. We're going to go to infinity, and it won't be a problem by then anyway. There'll be different problems. Okay. And we just take 350,000 times 0.73 to the n. Do we know how to do that? Any thoughts? I hope as you do, but that doesn't mean you remember. No, it's not an integral. No, we can actually get the exact answer. Integral would be an approximation. That wouldn't work. We'll talk about that on Friday, the integral versus the sum. That's Friday, and we'll see that there's some issues. Yeah, Suzanne, you got almost the right idea, except you forgot your decimal point. But I think you know what you're talking about. So let me go through it. So it's going to be, this is a geometric series. And when you have a geometric series, and notice that r is less than 1 in absolute value, and if r is less than 1 in absolute value, the first thing this converges, which is good, by the way. Otherwise, it would be a disaster, and it'd be a bad model too. And the idea is you can do 3, 5, 0, 0, 0, 0. In other words, you do, if you have a times r to the n, then it's going to be a over 1 minus r. 1 minus, and r is 0.73. And I know this is small, so I'll make it bigger for you. Okay, and now I can just pop that in the calculator. And you get 1,200,000, how about 1.3 million about? I'm going to do some rounding. So around 1.3 million people, or Americans, will get it between now and the end. Any questions on this model? Any questions? Okay. Do you think it's a pretty good model? Do you think it's a terrible model? What do you think?
Pretty accurate for the data available.
Yeah, it's what we got. So here's the next question. And this is a question that is open-ended. It's not like it's a math question. What assumptions are included in this model?
No variance. Oh, assuming your vaccine is able to.
Yeah, so one of them
Prevent.
is no big variance, right? Which means the vaccine works, okay? There's a lot of more assumptions, actually. That's one of them. If there's variance, there's no model with variance, by the way, because we don't even know what a variant would do.
You're assuming no people from other countries can come into the United States who are already affected.
Actually, we're not, nah, because so few people would come in that it's not that important.
Okay.
Actually, especially since we get a vaccine, that's not a problem. That's not really an assumption. The variance is an assumption, though. Maybe I'll give you some more. Let's see. The rate continues in a straight line from where, yeah. So a big assumption, and this is a giant assumption, is 0.73 is a constant. Do you think that 0.73 is really a constant? What do you think? Do you think that's true? The answer is definitely not. And you want to hear something good? What do you think is going to happen? Do you think it's going to go up or down? Temperature a bit, but something more important, and that is vaccinations. So let me go back to the article, not the graph, but the article itself. And fully vaccinated 37%, at least one dose 48%. So we're going to have a big increase in fully vaccinated, because all those one dose people, we're going to assume that one dose people want their second dose. Okay, it's true of most people. And that's a big difference, by the way. So that 0.73 is going to go down. Okay, it's going to go down a lot. Okay, and then there's people that are not even at least one dose that will eventually get it, in particular children. Okay, so when you have something like that, then you play around with the model. So right now we have this A sub n equals 350,000 times 0.73 to the n. Well, we can play with that and we can change it. And you could say, well, yeah, it's 0.73 now, but we probably should subtract a bit, and we should subtract maybe some multiple of n, because the idea is that as time goes on, there should be less and less giving it out to other people, okay? Less transmissions. So that, that could be lots of ways of looking at it. And it could be something like, I don't know, 1 over maybe 1 minus n over 20. Again, create a new model. Okay, and there are models like this. I'm not going to get involved in all the different models, but this gives us a different sequence, and you can look at this and notice that as let's see. I want 1 minus, not want 20 minus. Let's see. Want to divide by a big numbers and increases. So I got that wrong. Sorry about that. So that might be 20 minus, how about, let me find one, 20 over n, (20 over n). We want this to get big as it increases, so 20 minus 400, I don't know, over n plus 20. Hopefully that works, something like that. And the point is, you come up with new models and you can get more accurate. And that is things like this rate, this 0.73 is not a constant. So you add some stuff with n's in it. I'm not going to get into the details of that, but you can come up with new models and you get a different sequence. And if you get a different sequence, you can get a different model and you can have different rates. And the idea is with vaccinations, this 0.73 is going to go down, not up. And that's why it's a minus. I think I'm going to erase this because that's just made up. But the point is that you can create a model. And that's a biggie. Okay. So the good news is we're going to be done with this soon. Isn't that nice? All right. Any questions on that? Okay. So now I have a bunch of examples that aren't as, relevant as COVID modeling, but I want to spend some time on a real model and actually do it instead of just run through like math examples, because it's important to know how to do things. We don't have a lot of math majors here. Even math majors have to do real models. But now let's go back to math examples. Let's see how you do. These aren't easy if you know what to do, hard if you don't. So I have some sequences. Let's see if we can come up with the A sub n. Yeah, heat drives away vaccination, and that's going to make a difference. And it's not necessarily the heat; it's the fact that people go outside; they're not inside as much. But I'm not going to get into all that because I want to. This is a math class, but you're right about that. We can talk in the office hours. I'll talk to you a lot more detail. Okay, but we have 1, -1, 1, -1, 1, -1, 1, -1. Hopefully, you get the pattern. Tell me what A sub n is. Very easy if you know what to do. There's not even any work to show, but you have to see it and recognize how to make it work. I'll give you 30 seconds. If not, you probably won't get it. Negative A sub n minus 1. Well, let's see if that works. Negative A sub n minus 1 minus 1. Yeah, but we want to do it explicit, not implicit. And that actually doesn't work because if you plug in 1, -1 minus 1 is -2, and that doesn't give you -1. Okay, so the hint is it's very simple. Okay, I don't see y'all jumping in with it. So let's take a look at this. We have the odds are positive and the evens are negative. There we go. Adam's got it. And you got to come up with a function where if it's odd, you get positive. If it's even, you get negative. Okay. Or you can count it started at 0. You could choose. If you start at 0, it's a little easier to write. But if you don't, if we start at 1, then it's -1. And what I like to do is I write -1 to the n and realize that doesn't work because if n is 1, it gives you -1. So I go +1. And that's the answer. There's nothing more to it. But it is important if we see plus minus, plus minus, plus minus, you're going to see a -1 to the n or a -1 to the n plus 1, one or the other. Okay, let's look at the next one. 2, 5, 10, 17, 26, 37, 50, 65, 82, 101, ... See if anyone can come up with it. This is about being clever. It's not hard math. It's clever math. You have to see patterns. So it's a puzzle. And you have to see what do these numbers all have in common. Three plus 2n. Let's see if that works. If n is, let's say, 7, that would give you 3 plus 14, which would be 17. But here's 1, 2, 3, 4, 5, 6, 7. It should be 50. That didn't work. Plus? Not sure what plus is.
Every time you add a new number, you increase it by 2.
Okay, but remember we're doing explicit, not implicit. That would be an implicit or recursive. That'd be a recursive defined definition. We want the explicit function. What do all these numbers have in common? That's the key. Anyone see it? All right, here's a hint. Subtract 1 from all the numbers. Tell me what, then see what they all have in common. 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. They all have something in common that hopefully you recognize. So again, 1, yeah, they're perfect squares. So that's just going to be n squared plus 1. A lot of the hard part about this particular chapter is recognizing patterns. Okay, and it's not like I can tell you the trick. You just have to recognize it. Okay, how about 34, 30, 26, 22, 18, 14, 10, 6? See if you can tell me what that one is. And hopefully you can. The hint is this one's similar to the quiz. Yeah, 34 minus 4n. Right, because this is an arithmetic sequence. Start at 34, and then you go down 4 each time. Okay, how about 1, 2, 6, 24, 120, 720, 576. This one's a really important one. See if you can tell me what it is. This one's a tough one. And this one, it helps to see what you have to do to get to the next number. What do you have to do to get from 6 to 24, and then 24 to 120, and then 120 to 720? It might help, because you probably don't recognize numbers like 576. Okay, if you do, that's great, but you probably don't. Unless you're a total nerd like me. You don't see it? Okay, let's take a look. I can get from 1 to 2 by multiplying by 2. I can get from 2 to 6 by multiplying by 3. I can get from 6 to 24 by multiplying by 4. Do you see the pattern? So another way of saying it is 24 is 1 times 2 times 3 times 4. 120 is 1 times 2 times 3 times 4 times 5. How do we write that as an explicit function? Yeah, n factorial. Very important. It's hard to explain why it turns out to be n factorials come up, I'd say, over 75% of all important sequences in series. Okay, I don't think I'm going to do all of these because we're running out of time. 700. Oh, sorry, I think that's a typo. Sorry about that. So I'm just going to drop that one. I apologize for that. That was a typo when I typed it in. All right. How about this one? Find the summation n equals 0 to 50 of natural log of n plus 1 over n plus 2. How do we do that one? Any suggestions? Okay. I don't see y'all jumping in. Do you remember there's a logarithm rule when you have division? How does that work? Do you remember? Yeah, we subtract. So that's going to be natural log of n plus 1. Oops. Minus natural log of n plus 2. Can we do this without having to, add them all up one at a time? Because I don't want to do that up to 50 of them. What do you notice about this series? Starts with a T. Okay, let's write out the first few. Natural log of 1 minus natural log of 2. Ending with trig. No trig on this one. Good try, though. Okay, and then plus natural log of 2 minus natural log of 1. Sorry, of 3. And then plus natural log of 3 minus natural log of 4. Troop? Telescoping. Telescoping is what you're probably trying to remember. I hope that's what you're trying to remember. This is called a telescoping series. So when you have a telescoping series, it's very easy. You just say what cancels? Everything except natural log of 1, which, by the way, is really easy. And then notice that each time you don't cancel the last term. So the last term is going to be natural log of 52. So it's going to be natural log of 1 minus natural log of 52. And you better all remember what's natural log of 1? Yeah, it's 0. So it's just negative natural log of 52. Okay, I did it. No calculator needed. I'm done. You don't have to do 50 different things. You just realize you have a telescoping series and you're able to come up with the solution. Okay. By the way, the limit does not exist. If I put an infinity here, that does not exist because natural log of infinity is infinity. So that one doesn't exist. But if you stop at 50, you're okay. Any questions on this? We don't have time to do this one, but we can talk about it. Okay, I got this out of the book. Find the length of the zigzag path below. So we got this triangle, right? It's an isosceles right triangle with base 1. We're going to start over here. We're going to go to the midpoint. And then we're going to draw a horizontal line. And then keep going like that. Go to the midpoint of what's left and go and go and go. And if we want to find the length of this, what do we have to do? If we want to find the total length, we add them up. And you add them up by figuring out the equation for this one and this one and this one. And also this guy, the horizontals. And you're going to have 2 infinite series. And then you add up the infinite series. Okay. And I'll let you play with it if you want. But it's 10:15. And I don't like to go over if I don't have to, because I don't want to keep you from getting to physics or whatever you're getting into. I'm going to stop the recording.